welcome. This is the last lecture of this course, and I think we have spent enough time and we understood lot of modeling, theory, architecture, analysis, design, Verilog HDL programming. Then we have also learned STM32, C2003 microcontroller programming, and then we have considered a lot of case study of experimental case study. So, this lecture I want to summarize the key takeaway as well as the team introduction and usefulness of this course for skill manpower development. So, I will first summarize the course outcome and its usefulness and the key takeaway. Then I will introduce our NPTEL course contributor and the team members. Then I will introduce our embedded power management lab and what we do so far, or we did so far, the pedagogy and the skill development, as well as what research and development activity are going on in our EPM lab, that we will discuss, summarize, and then finally conclusion and some future scope. So, in this course we have, in the week 1 we have discussed about introduction to digital control in switch mode power converter. Then week 2 we have considered fixed and variable frequency digital control architecture. Then week 3 we have developed MATLAB custom model under various digital control. Then week 4 we have considered the modeling technique and the model validation using MATLAB. Then week 5 we have considered frequency domain and frequency and time domain digital control design approaches. Week 6 we have considered digital control implementation and FPGA based prototyping. Then week 7 we have considered introduction to Verilog and Verilog HDL as well as simulation using Xilinx Webpack. Then week 8 we have discussed digital control implementation using fixed point arithmetic and Verilog HDL. Week 9 we have discussed digital control implementation using microcontroller using STM32 and C2000 series microcontroller. Then week 10 we talked about step for FPGA prototyping of digital voltage mode and current mode control. Then week 11 we have considered design and validation case study using digital voltage mode and current mode control. Then we have discussed in week 12 hardware case study of advanced digital control technique, for example multi-mode control technique, frequency spread spectrum technique, and then finally course summary. So, in this course if we want to summarize the outcome, we have learned various level of digitization in closed loop switch mode power converter. We have also learned lot of modulation and sampling technique in fixed frequency digital control. We have learned modulation and sampling method in variable frequency digital control. Then we have learned custom model development using MATLAB Simulink for it is a customized MATLAB script as well as Simulink interactive MATLAB simulation for various architecture. Then we have discussed the overview of modeling technique with their complexity and what accuracy aspect. Then modeling of closed loop digital control and the step for model validation. We have also discussed the design method for fixed frequency digital voltage mode and current mode control technique. We have also developed lot of synthesizable Verilog HDL code for fixed and variable frequency digital controller. Then we have discussed what are the steps for Verilog HDL based digital control implementation and FPGA prototyping. Then we have also developed discussed presented lot of hardware prototyping and live demo with multiple experimental case studies. And we have also discussed software and firmware aspect of FPGA, STM32 and C2000 series microcontroller. Then we have discussed Verilog HDL synthesis for multi-mode digital control techniques. So, in summary we understood various digital control architecture. First, fixed frequency voltage mode and current mode control. These are already available in many commercial products. Then we have also discussed constant on-time digital current mode control. These are very powerful solution for future product development. These are already being used for multi-phase and other low duty ratio high frequency application. Then digital constant on-time voltage mode control is a cost effective solution for high frequency application. Current mode control is also very useful for the multi-phase and also other application where we need a precise current regulation. Then constant off time digital current mode control, this is also very powerful solution for LED driving, battery charging application. Then we have discussed mixed signal hysteresis control which can achieve very fast transient response, and we have also learned uniform and event based sampling technique for various modulation technique. In fact, these are kind of developing an upcoming research topic, and one can keep watching what is coming, but these are very important aspects for various modulation techniques. Finally, we understood the challenges of cost, power, delay, then stability analysis, and what are the methodology for design to design this digital control method. In the context of modeling, analysis and design technique, we have learned that continuous time small signal model, which are simple and insightful because it gives us pole zero concept, it gives us the concept of input impedance, output impedance, audio susceptibility, and they are reasonable to capture small signal behavior by including delay effect, but they are not sufficient to capture fast scale instability, particularly because these models simply ignore the ripple information, and those can be very useful to predict various instability in digital control. Then we learn discrete time small signal modeling, which are very accurate. It can capture all sort of instability, but these methods are mathematically complex because you have lot of matrix, exponential and all, and these are less intuitive in terms of pole zero. So, the effective way to design small signal based control, one can start with a small signal based continuous time small signal model by incorporating the delay, the lump delay, and this we have discussed in week 5, and but we need to finally verify our phase margin as well as the stability by using our discrete time small signal model. So, we need to use this combination of these two. The starting point will be continuous time small signal model, which are intuitive and which actually map into various kind of impedance shaping and other technique. Then we have also discussed the alternative small signal design method, which earlier we have considered stable pole zero cancellation, but we found this technique are very non-robust because we cannot exactly cancel pole and zero. Of course, also these techniques are not very effective for shaping output impedance because we are mainly targeting the loop shaping approach, but in closed loop output impedance we also have an open loop output impedance in the overall transfer function. As a result, these methods are not kind of robust when the load current varies. Then we have discussed an alternative small signal design method, I think week 5, and we found this method of PID controller, digital PID controller are very useful, it can achieve almost load insensitive design, and we have discussed in week 10, I think week 11 we have considered this, I think lecture number 103 to 105, we have used this method to simulate as well as we have experimentally applied this technique for the digital control implementation. Then we have also discussed large signal tuning, because how can we apply the large signal approach to achieve near time optimal recovery, and under practical constraint how can we scale those gain and what will be the effect, that we have discussed in detail, I think in lecture in week 5, I think it is lecture number 47, 48, 49 we have discussed about. 49 particularly is dedicated for the large signal tuning under practical constraint, and these are very useful for fast transient response. Then we have discussed lot of Verilog synthesizable digital control architecture, and we have discussed the fixed point implementation and the concept of Q format. In fact, this concept is the basis for digital control for coefficient scaling, and to get the to develop any type of digital control, PID controller, PI control in this architecture, and this will be very useful for digital control IC as well as microcontroller based system development. Then because most of the low power commercial product they use fixed point implementation, but if you go for floating point processor they are quite expensive and power hungry. So, depending upon the application requirement, if you are talking about just a battery charger, onboard charger, or you can power management IC, most of them go by fixed point. Then we have discussed lot of Verilog HDL programming, and we have all understood what are the steps for FPGA prototyping. In fact, this is one of the very crucial steps, because this question often comes, why should we go for FPGA rather than microcontroller? The answer is we are not going to use FPGA in our product, but FPGA is using for prototyping. But whatever we have developed Verilog HDL program, synthesizable code, this can be easily imported to come up with an ASIC power management IC solution. So, that was the whole purpose in this course. That means it will enable the designer to develop synthesizable HDL code which can be imported to any digital design flow tool like a Synopsys or Cadence tool, and one can come up with IC development, particularly for digital control for sure. Then if before going to the IC design, first step we want to verify whether your control logic, timing diagram, everything is working fine. We can very quickly prototype, and this can save the time to market. So we can have a very faster time to market. We can develop technology more rapidly. So that was the purpose. But FPGA may not be used in the final product. Final product can be either microcontroller for high power or for low power, high frequency application. For IC implementation, people directly go for ASIC. But this HDL which we have discussed in detail, that can be very useful. Then if we go for multiple fixed, and we have discussed multiple fixed and variable frequency digital control architecture, we have developed multi-mode control, we have developed variable frequency digital control, fixed frequency digital control, and all this control they can spectral spectrum technique, and we have developed synthesizable Verilog code. This can be very useful for new digital control IP as well as IC development. And finally, the multi-mode digital control using Verilog code can be very powerful solution for future IC development, PMIC, which can offer fast transient and high efficiency for a wide operating range. Now, the usefulness and the key takeaway of this course. So, this course will help you to understand the digital control architecture, modulation and sampling technique. So, this will be key enabler because your most of the industry, semiconductor industry as well as the power supply industry, even the high power supply, they are slowly shifting towards digital control. So, this course can enable to understand what is the basic digital control architecture, some sort of a few advanced architecture, some aspect of multimode. This will help to identify, understand what the competitors are doing, to understand what can be done to get better and what are the practical limitations. Then this understanding will help to come up with new architecture based on application requirement. Suppose if your power requirement is high, for example, you are talking about on-board charger, off-board charger, the charger power rating is more than few kilowatt, where you can afford to have a microcontroller which can consume few watt power. But imagine that if your power level is few hundreds of watt or maybe few tens of watt, then you may not be able to use a dedicated microcontroller. So you may have to use a power management IC where the controller can be a separate IC. We have discussed in server application where the digital controller IC is used to centralize control all the phases. Similarly, if there are multiple POL for automotive application, you can have a core digital processor which takes the algorithm. It can have a central algorithm. It can communicate with multiple converter. So all these features are very helpful. We have learned a lot of MATLAB custom model development. This will give confidence. Before going to any hardware implementation, Verilog coding, it is very important to come up with a new idea. Once the new idea comes, suppose we have an idea about fixed frequency control with either uniform sampling or event based sampling, or we want to sample at some instant of point based on customer or our choice. So our custom model development flow, which we discussed in week 3, will enable you to build confidence, develop whatever concept you come, it should be implementable in MATLAB by using custom difference equations that we have discussed. So it will give you confidence. The modeling, analysis and design tool will be very useful to understand the stability aspect, what are the cause of instability, how can you make it stable for fixed frequency as well as variable frequency digital control. Though we have not covered the stability aspect of variable frequency, these are more advanced topic. So one can go through our publication, and we have multiple research work based on the stability analytical tool for variable frequency digital control also. We have discussed lot of Verilog HDL programming, and I think we have many lectures on Verilog, including week 7 is complete introduction of Verilog HDL, and based on that Q formatting we have developed lot of controller architecture. This should be synthesizable to come up with digital controller. It will give you confidence to the designer to better understand Verilog, but one can go for VHDL also. But HDL programming understanding, circuit understanding, and what we solve in all cases, we have not started Verilog from the very basic, from the very beginning. we first drawn the equivalent digital circuit. We tried to go deep into the circuit, identified what are the actual digital circuit inside. Once you know the digital circuit, whether it is a sequential circuit, combinational circuit, then we can write Verilog code without very rarely to have any error. So that means the best way to write Verilog code, first to draw the circuit, understand the concept, draw the circuit, then try to write the Verilog using structural or data flow modeling, and as much as possible to avoid behavioral modeling, or instead of writing full algorithm level, we should implement the circuit level thing in Verilog. Then we learn about the step for FPGA and prototyping. I think this will be very powerful. Those who are not familiar with the FPGA, they can quickly learn it. They can use FPGA for prototyping, but actual controller can be microcontroller based product, or it can be ASIC development. So this course will give a glimpse of what are the steps for FPGA prototyping. Though we have used a very cost effective Xilinx FPGA, one can go for Altera FPGA, other variant of FPGA, or the very powerful FPGA. But the basic concept of tool development, the flow of prototyping, those will be useful. And finally, this course will be helpful for skilled manpower development, particularly to come up with the indigenous technology, to thought process. Sometimes we have many idea, but we may not have right tool to validate. We can start with a simple MATLAB, then one can go to Simplis, and they can come to the Verilog HDL based FPGA prototyping. So this skill manpower development will try to create an ecosystem for the corporate research and development as well as the product development initiative, that will be very helpful. Now coming to, after so many courses, I mean this course would not have been possible without the help or the active cooperation of the team. So I want to introduce the NPTEL core team. This is myself, who was the course coordinator, and and this is our teaching assistant, and this Deepayan Chatterjee, Anirban Nando, then Gopi Reddy and Teja Golla. They are my PhD students. They are the TAs, and they help, like they have worked tremendously to come up, assisting me to develop the content. These are very helpful. Then I want to appreciate our contributor from industry partner. Particularly, I want to thank Mr. Ranajay Mollik and Akshat Jain. They have actually put a lot of effort, in fact, to develop some content of STM32 microcontroller based digital control implementation for LLC converter case study, and they have developed that hardware prototype and tested, and the design aspect. I think that will be very useful. Those who are working for EV, you can go through that LLC converter design aspect as well as implementation. I also want to thank our industry partner from Texas Instruments, that Arvindan and Aditya, who actually help develop the firmware and software introduction of C2000 series microcontroller, and they also touch upon one case study of power converter, which is like a bidirectional totem pole PFC. And I would like to thank Nitin Nigam from Keysight Technology, who actually came down to our campus to develop few videos on how to use mixed signal oscilloscope, what are the functionality. So I want to thank all the industry contributor and our teaching assistant. Now as an extended team member beyond our TA, first of all we have teaching assistant who has helped. We have other student who has immensely helped, like Prantik Majumdar, Ruturaj. They have actually helped a lot to develop this hardware prototype, tested. They are my senior PhD student, Avijit Kesri, who was a MS student, very helpful in assisting me to developing that Verilog part of this course. Then Kelvin Paul, Faraj Ahmed, they are my PhD student. They are help whatever we need help, they came forward. Then Dhiman Das, who actually was spent for a short time with us, who helped also to come up with the power stage PCB aspect, design and the fabrication. Then Saurabh Sahu who actually helped processing all this video and on time and making this very high quality content. Then I just want to briefly introduce about IIT Kharagpur, and as you know, IIT Kharagpur was the first IIT among the all IIT chain, and it was established in 1951, and I feel very proud and happy to be part of this institute, and my MTech PhD also of this from this institute. And this is a department of electrical engineering where I was a student, and also I am also a faculty member, and this department started in the same year of IIT Kharagpur inception. And so this department we have active faculty colleagues who are working on very active in research as well as industry collaboration. This is our embedded power management lab, and this lab we have it was developed and it was inaugurated in 2014, and we have almost come across 8 years span. And this past we have industry collaboration like ST Microelectronics, Qualcomm, NXP, G Global Research, and Texas Instruments, HCL Technology. We have collaborated either in the past or present. We are collaborating with some of them in the various form in terms of research collaboration, consultancy, training program. And in the embedded power management lab, actually we have like 6 PhD students who have completed out of this embedded power management lab. 10 PhD students are ongoing. They will be slowly they will be finishing their, some of them will be finishing PhD soon. And we have more than 20 MTech students graduated from this lab, and 1 student is now going on. 2 MS students have are graduated, 1 MS student is still continuing. So, and some of the alumni that graduated from this lab like Hariharan, Ravi Shankar, Indar, Amit, Bipin, they have finished PhD and they are doing good. And Somnath, actually he is about to finish PhD soon, but he is now in industry. So, Abhishek Pal and Arnav Acharya are the 2 MS students, and they are already Abhishek is with Texas Instruments and Arnav is doing PhD at Arizona State. So, right now we have 10 PhD students including Somnath, who has joined lab, and they will be slowly finishing, and they are quite active and very energetic. I would say we have fantastic team here, and Abhijit Kestri also MS student. So, the major research initiative in our EPM lab, I think more than last 7 years, we have initiated the digital power management research and developed multiple intellectual property. We have developed various tools for analysis, design, and filed multiple patents. We have published more than 90 papers in IEEE journals and conference, and out of that 35 APEC paper. Then industry partner, we have ST Microelectronics, Qualcomm, G Global Research, NXP, Texas Instruments. Then major external funding, we have more than 5 crores of Indian rupees fund from government agency and industry. We have offered multiple courses for industry like ST Microelectronics, Qualcomm, HCL, NXP, and we have been serving actively on various IEEE journal in the editorial board. In the pedagogy and the industrial training program, we have offered courses on modeling, control of switch mode power converter training for ST Microelectronics, Qualcomm, and HCL, as well as NXP. Then develop NPTEL online certificate course for control and tuning method in switch mode power converter. In fact, this course is the basis of that current course, because this course we developed last year and it is also running this year. This course we developed the fundamental concept of constant on time, ripple based control, various modeling technique, and we have referred various lectures of this course in this particular course and the available YouTube. And we are developing, in fact, we have completed this digital control this course, which will be also running for this time now. So, we are also carrying out industry oriented research, that means with ST Microelectronics we are working on intelligent digital control development as well as reference design, SiC based high power bidirectional converter for EV charger and DC grid. We are working on ST Microelectronics also in the ASIC power management IC for single injector multiple output converter. Then we are also working with Qualcomm in the modeling and control for mobile power management application. We have worked with GE Global Research for GAN based digital control for dual active bridge converter, and NXP we have worked on class D audio amplifier. The ongoing research, we are working on data center and the cloud computing for high performance energy efficient digital control, the GAN based power supply for charger, ADAS, multi-phase hybrid converter, portable and mobile application for fast recovery high efficiency power supply. Automotive, we are working on GAN and SiC based EV charger auxiliary power supply and ADAS. Then we are also working on solar microinverters and for GAN and SiC based solution, hybrid converter and digital control. Then we have many unique tool in terms of analysis and design, which has different level of complexity and accuracy, and this can capture all type of control, their stability analysis, both large signal and small signal tool. The future research challenges, if you talk about the DC, data center application, mobile phone, even the automotive, it has multiple DC-DC converter, multi-phase, single stage, envelope tracking for ADAS in automotive, as well as for data center application also there can be 5G communication. So, where the multiple converter communication, the performance indices will be power density, then efficiency, performance, cost, reliability, time to market, scalability, interface and adaptability. So, this will have enormous implication for future digital control development, and the opportunity will be wide bandgap based devices and power supply on chip, because we want to achieve high power density solution. Then we want to achieve high performance distributed control for such interconnected DC-DC converter network, and we need to also achieve very high performance and dynamic power solution with optimization. But the challenges will be the converter topology selection, modulation technique in the context of digital control. What is the right control technique? What are the sampling and the tuning method? Then how to reduce conductor and EMI aspect, and the packaging technology will be helpful. So, some of this part we touch upon in this course to show what are the challenges, some idea about, let us say, frequency modulation for EMI reduction and tuning, control, sampling, but this is just the beginning. In more development will happen in the near future, and industry will also slowly shift toward digital control for adaptability, and all these performance index become crucial. So, in summary, we have discussed the summary of this course, its usefulness and key takeaway. NPTEL course, we have team member, we have introduced our embedded power management lab, we have introduced IIT Kharagpur, our department of electrical engineering. Then we have discussed what are the pedagogy and the skill development program we did, and what are the research and development activity we are doing, and finally we have shown some future scope and the conclusion. And in summary, I want to say, I hope this course took enormous time, because this course probably will be unique in terms of it has theory, then it has MATLAB programming, then it has Verilog HDL programming, FPGA implementation, then the step for HDL synthesis, then hardware implementation, experimental result. Then we have also our invited speaker from industry, they have presented STM32 hardware firmware aspect. From Texas Instruments, they have presented hardware software aspect of C2000 microcontroller. So, in some sense this course give a glimpse of most of the popular digital control platform for both prototyping as well as commercial solution, but this is still kind of a just initiated the digital control thing, and in future we will find more and more digital control development. And I hope in this context this course will be useful for IP development, product development, and it will give up I think boost in the confidence level and adapt with the digital control solution for indigenous technology development. So, this course I hope will be useful for both industry practitioner, then graduate PhD student, MTech student, and the students of other academic institute, as well as I would say different professional different profession, the technical persons. That is it. I think, thank you very much, and I hope this course will be useful for all of you. Thank you.